someone told me that I spelled the word function wrong, so I don't know. Anyways, so we're on 3B.6, part one. So you should have gotten the notes on Monday. So we have part one and part two. Part one, it's a quashable book. Okay, it did not print how it was supposed to. So just you have some creativity with how you fold it. All right. Yeah. So let's dive in. So do you guys remember how we've learned before functions transform, right? Everyone has a parent function. Same thing for trig functions. They have parent functions. Those parent functions are what we were learning and talking about in 3B.4 and 3B.5, okay? That's what your quiz was over, was just the general parent function of cosine and sine, okay? So just like all parent functions, your functions shift, they change. The difference here is that when we've been describing the transformation of the parent functions, we've actually have been describing in terms of the midline, the amplitude, and the period, okay? The midline is a vertical translation. That's all it is, okay? The amplitude is a vertical dilation. That's all it is. And your period is just a horizontal dilation, okay? The dilation is describing where your function is being stretched or compressed horizontally or vertically, okay? And we learned all about transformations in Unit 1. All right, so it's the same things, just with a new hat on it. Got it? So again, a midline is it right? There we go. A midline is just a vertical translation. Amplitude is just a vertical dilation. And period is just your horizontal dilation. So transformation variables. Your transformation variables are set up very similar to all transformation variables that we've learned thus far. So if I'm looking at f of theta, which we're going to call sine. So f of theta is a sine transformation variable. You have your A, your B, and your D right now. Okay, there is a C, but C is in our part 2 of our notes. Got it? So A is going to describe our vertical dilation, aka our amplitude. Okay, your B is going to describe your horizontal dilation, aka our period, and your D is going to describe your vertical translation, aka the midline. Okay, so same thing goes for cosine. So KF theta, we have A, B, and D in the exact same location. The only change is from sine to cosine. So again, your A is your amplitude, your D represents your midline, and your B, remember, X's are liars. So even though it looks like it's multiplication, it's actually what? Division. Okay, even though it looks like multiplication, it's actually division. Okay, it's going to be 1 over B, which means that your period equals 2 pi divided by that B. And it's going to always be absolute value because you're just describing the distance. Does that make sense? What? This is multiplication. So the opposite of that is 1 over B. Yes. All right, so let's dive in and see how this works. So up first here, we have graph H. So the graph of the sinusoidal function H is shown on the figure above. Notice that I didn't say it was sine or cosine yet. I just said sinusoidal, meaning that depending on where I look at, what interval I'm looking at, it can either look like a sine graph or it can be analyzed as a cosine graph, okay? The beauty here is that the A, the C, the A, your B, and your D are going to be the same, whether it's a cosine or a sine graph. Does that make sense? So those 3 things are going to be the same across the board, all right? So it's telling us to write h of theta in terms of a sine graph. So it does want us to analyze it as a sine graph. So we have to find our A, our B, and our D, okay? So the first, find our A. We said A represents our what? Your vertical dilation, your amplitude, right? Yes, we know where I'm getting that from. No one's thinking I'm crazy. Your A is your amplitude, okay? So A is simply 6. And that's coming from our graph. So we see that our amplitude is 6. The reason why our amplitude is 6 is because the distance from our midline to our max is 6, correct? You with me? All right. Next we're going to analyze our B. To find our B, we use our period, okay? So to find our B, we have to use our period. And that's because our period equals 2 pi divided by our B. So if I know my period, can I solve for my B? Yes. So looking at this function, it starts here at 0 and it ends here at pi. So that's why my period is pi. Yes. So we have pi equals 2 pi divided by B. A little quick cross multiplication and divide, and we can find our B. Make sense? I'm going to cross multiply. This gives me B pi equals 2 pi. Divide by pi. So therefore, B equals what? 2. So now we have our B, we have our A, and the last thing we need is our D. Your D is your midline. And our D is 3, because our D is our midline. So we have our A, our D, and our B. Can I write the function? So H of theta equals A, our amplitude, which is 6, sine, our B, which is 2 theta, plus our D, which is 3. And that would be our model. Questions?
How did you get 2?
How did we get our B equals 2?
Oh, wait. That's 6 pi. Yeah, is that 6? 6 pi? Like, come on.
Where do you see 6 pi?
I think about the B. What is that B?
It's a B.
Okay.
That was my B.
The angle. We go.
Yeah.
Also, that's another B. H equals.
Yes.
Okay, equals B sim.
This is a B, not a 6. It didn't.
No, I'm talking about the.
That's why it literally said in the beginning, using 3B.4 through 5, we're going to build on that. Yeah. That's the first thing I wrote so that you wouldn't accuse me of that. See it? Yeah. Okay, ask me questions. I mean,
Is that? I don't know how to explain, but where the sin is at in the answer, is that supposed to be a B? Like B?
No, it's a 6.
Okay.
My
So
amplitude
6.
is 6 sine 2 theta plus 3.
Okay, I understand.
Because your amplitude is your A.
Wait, is that theta?
That is a theta.
I know, but I didn't know this one. I thought it was a B right here.
Okay, I'm going to try again. I thought we were okay, but let's do it again. See what happens. All right, so this time on the first one, I marked everything for you, right? This time we're going to analyze, because we learned how to analyze the graph in 3B.4 through 5. And then we're going to identify what's my A, what's my B, what's my D, okay? So in order to find these things, we have to figure out what is your amplitude. So what is the amplitude of this graph? And our last notes on Tuesday, we talked about the amplitude is found by finding the midpoint between your max and your min, correct? So the max here is 6. My min here is 0. What is the midpoint between 0 and 6? 3. Yes? That's my midline, right? So this is, well, midline, sorry. Okay. So 3 is at my midline. And because my midline's at 3, then what is my amplitude? It's also what in this case? It's also 3. So we have our midline. We have our amplitude. Now we need to know our period. Okay. So looking at this graph, even if no matter how I analyze it, I'm going to just go ahead from the midline to where the midline stops. I'm going to analyze it as a sine function. Do we see that? So for this sine function, what is its period? What is the period? It's just pi. It takes 1 pi for the cycle to complete. Do we see that? Okay. That's what we learned how to do in our previous notes. This notes is now taking that information and turning into terms of transformation. Yes? So now, based on what we know, what is our A variable for transformation then? Our amplitude, which is 3. What is our, I'm going to go jump to D. What is our D variable? It's going to be 3 as well. And then my B, it's just going to be 2. Okay? Remember, your B comes from using your period. Your period equals 2 pi divided by your B. So if my period is pi, you can do a quick little cross multiply, right? It's the exact same one, but we'll do it again. And we get 2 pi equals pi times B. Divide by pi, divide by pi. And what is our B? Our B equals 2. Do I have everything I need to write the function model? So f of theta equals your A. What's your A? 3 sine. What's your B? Your A goes first. Sine. What's your B? What is your D? Plus 3. Okay. Yes. Okay. So, what I want to point out is your amplitude is going to always be positive. The only way that the function would be negative is if instead of starting with a max for your sine, you start with a min for your sine. So if I start off as a minimum, then when I write the function model, it's going to be a -3. Does that make sense? Why would it be a negative? Because I'm not increasing and then decreasing. I'm doing the opposite. I would be decreasing then increasing. So it would be me rotating around the unit circle the opposite direction.
Oh, like a vertical flip.
Okay. We did it in 3B.4, 5 minutes.
I'm talking about the 2 pi. 2 pi equals.
You didn't need to do that. You just had to tell me your period. Yeah. I just needed to know the period. Where did it start and stop, buddy? I don't know why you did that. Huh? All right. Example 3. This is an example of a possible multiple choice question about analyzing a sinusoidal graph function. So it says here, what are the values of the period and the amplitude? Go. This you should know from last section. What is the value of the period and the amplitude? All right, somebody, everybody, scream. What's the answer? It is A. You should have gotten A. Okay, looking at it, amplitude from your midline. So my midline's at -1. How far from my midline to my min, or how far from my midline to my max? And that is only 2 units. Your period is whether you're following it as a cup or if you're following it as a snake, a sine, how long does it take? So it went from 0 to pi. So it took me 1 pi to make my cycle. So it should be that. Okay, and this is an example. If I'm analyzing it from here to here, this would be a negative sign because I started off as a minimum and then became a maximum. Do you see that?
I have a question.
Yes.
So the amplitude is two because what?
It's the distance from your midline to your max or your min. It's the distance between from your max to your midline. All right, let's try another one. Okay. Here is another example of a possible multiple choice question that you would see. Again, this would be all on the non-calculator part of the test. Trig function k has a maximum point at 0, 6. After this maximum, the next minimum occurs at pi over 2, negative 4. Which of the following could be an expression for k of x?
I just picked a random one.
That's terrible.
Hey. Oh, do you like my shirt, by the way?
Yes, love it. Outcast for life.
Oh, yeah.
All right. So a couple things you got to identify here is what is your amplitude? Where's your midline? Where's your... So I'll let you think about it. If you need to draw a little sketchy sketch to start. And our previous notes. Yeah, exactly. So Randy pulled out her 3B.4 through 5 notes and noticed that we did a similar problem there. Okay, so we got our amp. Keep going. Huh? I didn't say you're wrong. Yeah.
Oh,
It's on paper. Why did I write half period? It's just from a max to a min, right? It's only going to be halfway through, right? So if I need that 1 pi, so I'm going to find the distance. Remember, when you're analyzing the period, you're finding the distance from where you start to where you end. So I ended at pi over 2. Pi over 2 minus 0 is just going to be pi over 2. So I know my period is pi over 2. And this equals 2 pi divided by my b. Well, times 2. Hold on. That's not right. You saw. So a full period would be pi. I forgot to multiply by 2 to get my full period. So a full period is pi. We've done this enough now to know that if our period is pi, what is your b? Your b has to be 2. So that automatically eliminates A and C. Okay, right? And then your midline is the, how do I find my midline? The halfway point, right? The average between your max and your min. So we have 6 plus negative 4 divided by 2 is equal to pi. So then last but not least, so it would have to be D. I didn't make you think guess yourself. You got to be confident in what you're doing. C. Oh. So my midline. So my amp will equal 6 minus 5. 1. I can do math. I wrote that backwards. I was writing ahead. Yes. Sorry, my bad. Let's try that again. Bye. Joke. Honey. Now take a picture. I had to finish writing it. No, take a new one. I didn't finish it. I was trying to fix it for you. Yes. You will have to wait a moment, sir. See. Nope. I need to get my life together. I haven't did it this year. All right. Are you ready? Another example. Here we go. This time, you're matching the function to the graph. And go. All right. What'd y'all get? You got what?
I got C.
I got C.
Oh, you tricked me? Okay. The answer should have been C. All right. So let's talk about why it's C. So from here, you knew that your amp equal. What's your amp? 3. Your amp had to be 3. And your midline had to be at what? At -1. So those things right off the bat were first to look at. So I come up here to A. Which one is not being satisfied? Clearly isn't. And then here also, I can come look here. Is my midline good? No. So we're narrowing it down. Does that make sense? All right. Then after that, paying attention to your amp and then paying attention to your period. So your period is 2. Your B equals 2, which means that we know at this point that means our period equals high because we've done that so much, right? So we know that our period had to be high. So now I'm looking at where does that happen? Well, this is from here to here, takes me to pi. So therefore it had to be C. Yes.
Fair to say that our D or midline is always going to be the Y.
No. I mean, it can be. Yeah, it will. I had to think about it. It's just that you may not have the y-axis in view. So like that's why I wouldn't say if you see the y-axis, then that's where your midline is. But you may not always. No, that's when you're looking at a sign. Yes, it'll be fine. Yeah, sign. For sign function, it will be. We start note cards after this test. We start. Oh, you weren't here on Tuesday. Yes, we will be doing note cards reviews for every